Our second speaker, whom it would be rather easier to throw off the stage than Rick, is Parma. Anna, where have you got to? Oh, there she is. So Anna is one of our own. She got her PhD here at the University of Washington about 3 or 4 weeks ago, right? You're straight out of college.
I go grey a little faster.
Well, depends how your thesis went. What are you looking for?
The microphone that I stole.
Oh, yeah, please. Yeah, we're not quite as organized as the lawyers and the lobbyists. So after finishing her PhD, Anna then worked here in Seattle for the Pacific Pacific Halibut Commission, and then went back to her home country of Argentina. And I'll never get this right. You work for the Argentinian National Center for Scientific and Technological Research, right. And I will not try and translate that into Spanish. Anna has been involved in just about every fishery around the world, and although she's 3'5", is generally regarded as the enforcer and the only person who's actually been known to tell Ray Hilborn what to do, and he obeys really quickly. For today's presentation, Anna is going to give a summary of the National Research Council report on rebuilding fish stocks, and again I haven't got the whole title, but I'm sure Anna does. Anna was the co-chair along with Pat Sullivan of that committee. You've heard of it several times. It is one of those committees whose results are feeding into the process. Now let's see if we can.
So it shows this one.
Get rid of that.
What?
Yeah, save. Don't save.
Don't save.
Get rid of it.
I don't know how to get this. Don't save.
Go. That's gone. Okay. Okay, I'll leave it to you now that we've
Which
got
one
the
is this? No, we haven't.
What do you mean we haven't?
Down in the
Over
one?
here.
Oh.
right of the screen.
Oh boy.
There we go. Off to you.
Thank you. I think it's much more difficult to tell Andre what to do than to tell Ray. So that's my next challenge. Well, you heard people talking about this report that was recently released. So I was happy that, that the steering committee provided some opportunity for me to come and talk about some of the results of this study. This is just being released in paper form with this nice cover art by Ben Miller called Abstract Fish. So I was thinking today when there were some mentions of previous NRC reports, some of which I've been part of, leading to contradictory acts, and I'm hoping this is not as abstract and it's actually helping the process. So in 2011, NOAA commissioned the National Research Council to do an evaluation of the effects of the Magnuson-Stevens Act mandate to rebuild overfished stocks. This is to acknowledge my, my co-workers, and this is why I'm saying that Andrew was harder than Ray to actually follow advice. But I'm glad he's here, because knowing him, I know that he'll be able to jump in and rescue me if your questions become too tough. The task for the committee was to identify the changes that were made in response to this Magnuson-Stevens Act mandate in terms of several aspects, and my talk will concentrate mainly on the outcomes of the rebuilding plans as affected by the uncertainty in the assessments, the environmental considerations, and then I'll go back and make some comments on the methods and the rebuilding framework. Well, you got this in a lot of detail in the presentations this morning. So I just want to highlight here the two main amendments to the Act that define the framework for rebuilding. The first, the Sustainable Fisheries Act, that define overfishing in terms of the fishing mortality rate that will be in excess of that would maximize the long-term yield from a stock. Then the very important thing that it required the overfished stocks to be rebuilt, and it provided a limit to the time for 10 years with some exceptions. So any stock that could be rebuilt within 10 years, even if that involved shutting down the fishery, that had to be rebuilt in 10 years. The exceptions were biological. In cases where the stocks would not rebuild in 10 years, then they were given an extra generation time. In the 2006 amendment, then some of these mandates were made more stringent. There was a call to end overfishing immediately. Some of the initial rebuilding plans did not have that in place, so we were sort of phasing in some of the reductions in fishing mortality. But now, after 2006, then the requirement was that fishing mortality had to be dropped to FMSY immediately. Then there was a requirement for annual catch limits for every stock, and there was required accountability measures for cases in which these annual catch limits were being exceeded. Now you're experts on this curve after Rick's talk, so I don't have to explain it again, but the MSA also required that there were annual reports made to Congress on the status of each of the stocks. This placed a huge demand on the science, because for each of the federally managed stocks, there had to be an estimate of the status of the stocks, and there has to be an estimate of that level of associated with the maximum productivity, the level of MSY, and there has to be also an estimate of a minimum stock size threshold below which we would call a stock overfished. In addition to classifying stocks in terms of biomass, we had to classify stocks in terms of the fishing mortality. So every time the harvest rate exceeded that limit that was set at the fishing mortality associated with the MSY, then we would say that the stock was subject to overfishing. So these reports to Congress, they classify every stock, and I think it's about, Rick will know, but it's about 500 stocks or close by that have to be classified in terms of both the condition in biomass and the condition in fishing mortality. In terms of biomass, there is very many categories, because the stock can be overfished or not overfished, but they can also be approaching overfishing condition, rebuilding or rebuilt once they've recovered to above MSY after a rebuilding plan was in place. Over the period that was covered by the review, which went from 1997, so after the Sustainable Fisheries Act was passed, to 2011, there were a total of 85 federally managed stocks that were declared overfished. So this is the collection of all those stocks. And the majority were from New England, not the majority, but the area that had the most stocks was New England, with 29 overfished stocks, not at the same time. This is overall, over the whole period. Then it was followed by the Pacific Coast and the highly migratory species that had 14 overfished species each. The approach of the study was to evaluate the effectiveness of the rebuilding plans based on these 85 stocks. And we, at the start, we made the commitment to have a report that would be grounded on data. So I'm afraid now we will have to suffer through a lot of data that will run bio, because we didn't want to have just our pre-existing opinions, but really have to evaluate the outcomes. So the talk will cover two aspects. The first is how the management responded to these MSA demands or requirements for rebuilding. And the second part of the talk will be on the actual outcomes and how successful those efforts were. So as I said, not all the stocks, all those 85 stocks were overfished, declared overfished at the same time. The peak was initially, and most of the stocks were declared overfished within the first 4 years after the Sustainable Fisheries Act was passed. So by 2000, that was when a lot of the category that was undefined sort of became classified, and you can see how fast the agency had to move to really satisfy these demands from the Act. Then the number of newly declared overfished stocks dropped substantially, but there's been an average of about 6 stocks that had been declared overfished, new stocks declared overfished every year for the period between 2004 and 2010, and it's been dropping ever since. All the data that we'll be talking about stops in 2011-12, and that was the end of the study. So I haven't updated the numbers, and you can see that this is a very dynamic system, so some of the numbers are already old, because 2 years have passed since then. For each of these stocks that were declared overfished, the Act says that a rebuilding plan has to be put in place. So rebuilding plans were implemented for 79 stocks out of those 85. 5 of the stocks were reclassified as rebuilt. before a rebuilding plan was put in place, and 79 had a rebuilding plan. So for each of them, then there's got to be, especially the ones that have an assessment and have a quantitative basis to do this kind of analysis. There is what is called a rebuilding analysis that involves a simulation of likely stock status under a range of harvesting rates. And these analyses are used to select the key parameters that define a rebuilding plan. So one of the key parameters is this target time period for rebuilding, what we call T-target, which is in expectation or 50% probability when is it that the stock will reach, so will rebuild, will approach this BMSY under any given policy. The choice of these T-targets, so the target for rebuilding, is not free, is bounded by the T-min, which is the fastest the stock can rebuild in the absence of fishing. So the analysis, these simulations are repeated, and they're repeated under zero fishing mortality to determine how fast the stock can rebuild. So T-min is you cannot rebuild faster than that, so T-target has to be larger than T-min. And then there is also a T-max, which is the one that is set by the guidelines or by the law. That's where the Magnuson Act says 10 years, if at all possible, and if T-min is below, as is above 10 years, as in this case, T-min is larger than 10 years, that means there's nothing we can do. So in that case, we have an extra generation time. If T-min had been below 10, then 10 would be bounding the rebuilding parameter. For each of these T-targets that we pick, there is, in the case of a constant harvest rate policy, there is a rebuilding F, or F rebuild we call it, which is the one that will attain that T-target. So we looked at the 79 plans, and what we found is that 40% of the rebuilding plans that had been implemented were actually determined, the T-target was determined by this 10-year rule that is being discussed over and over. Some of the plans did not have a rebuilding time, but those were the minority, and then there's the 6 stocks that had no plan. This varies a lot over the regions, and in this rather complex slide, I'm comparing groundfish stocks from Pacific with New England in green and Pacific in gray. The length of the bars here are the fishing mortality that was used to set the annual catch limits in 2012. And then you also see here the numbers that talk about the time frame for rebuilding, for the rebuilding plan, compared to the maximum time that was allowed by the 10-year rule. Now, as you know, the Pacific has a lot of stocks that have low productivity, so the T-max are much larger than 10. That means they could not be rebuilt in 10 years. So T-maxes are very large, and you can see that the time frames that were picked were pretty far from the T-max. So those plans were not bounded by this 10-year rule, and they were not bounded by any rule. In general, the fishing mortalities that were picked were very low in terms of a fraction of the maximum limit. So the Pacific have opted, with this exception of the petrel sole, to use very low fishing mortalities, so have the periods for the rebuilding are much shorter than what they could have done under the law. When you go to New England, it's very different. New England Council has a rule that says that they will use FBF rebuild the minimum between the one that would satisfy the maximum constraint and 75% of FMSY. And if you can see the majority of these groundfish, the F rebuild was set at 75%. What that means is that the actual 10-year rule, for all the discussion that we have, is not really limiting the fishing mortality. We're picking 75% of FMSY based on other considerations like Rick was discussing before. But there is these cases that show where is it that the 10-year rule actually was hitting the fishery, and that's where instead of using just the rule to plan and to constrain the choice of a rebuilding parameter for the plan, they were actually trying hard to make that happen. So to make sure that the stock would indeed, in reality, rebuild by that period. So again, it's an important distinction to be made that when we talk about the 10-year rule, even in the cases where the 10-year rule was binding, the fishing mortalities that satisfy that rule were in most cases higher than 75% FMSY. So there's nothing really wrong with the 10 years. It was sort of like a reasonable choice in most cases. The problem was, and the much larger reductions in F were introduced when the rebuilding of abundance was slower than anticipated at the time the analysis was done, and then management was trying hard to actually meet that target. So it's a very different concept of using a rule for planning and for picking a harvest rate than to actually expect the stock to rebuild by that time. So I have two examples that will illustrate the problems that in some cases led to abrupt changes in regulations when this was happening. And these are two flounder stocks from southern New England. The first is a winter flounder, and in that case, it's an example of where the rebuilding clock, so these 10 years, was reset after major efforts to try to meet the original schedule that were unsuccessful. The other case is the Yellowtail Flounder, where the stock status was reclassified after updated stock assessment. So I'll start with the winter flounder. In both cases, the original plan was selected in 2004, and it was limited by the 10-year rule, so the original time to rebuild was 2014. The initial fishing mortality was up to something of 0.32, I think, for a number of years. Then there was a new assessment that indicated that the abundance was very low and that the stock was, they call it behind schedule, that meaning that the progress is slower than was originally anticipated in the projections that led to the plan. But it wouldn't build to 2014, but it would probably build to 2015 if the fishery was almost closed. So a zero retention limit was established, which had enormous impact on all the fisheries, because this is a complex fishery. They put in place a lot of measures, and they managed to reduce the fishing mortality to something close to 0.07, and that was the number used the following year to set the annual catch limit. By this time, they realized there was no way they would rebuild even to 2015. So the advice was to reset the clock, because now you can say that T-min is not going to be achievable, and then you start again, and now an increase, a high increase. So this is the type of disruptions that the framework, when you interpret the rule as meaning you actually have to achieve the rebuilding by that given time, is forcing into the system. The Yellowtail Flounder is very similar as the start. Again, a plan set to rebuild to 1420. Then the successive stock assessments indicate that the stock is behind schedule again. So there is an effort to try to meet the rebuilding target by reducing farther and farther the target fishing mortality. A new assessment in 2012. And then in the assessment, we had the original BMSY. The stock is very low, much lower than the threshold, so it continues to be overfished. But then there's two scenarios considered to actually try to explain this lack of progress through the 90s and the last 20 years. The first scenario is the original scenario that said that the BMSY was up there and the stock was heavily overfished with that value of MSY. The alternative is a regime shift scenario that says that the actual biomass is much lower, it's 10% of the previous one, and under that scenario, the stock is rebuilt. The review committee looked at this and evaluated that there was a 60% probability of the second scenario, so the stock was classified as rebuilt, and then you see the fishing mortality back up to the kind of the MSY level. So this is the problem of having a discontinuous harvest control rule that says when you are under a normal, what we call a normal harvest control rule, then you have a smooth response. When the stock is coming down, then the fishing mortality is dropping down. But now once you reach this level, and what I'm talking about 50% MSY, then you're back into a different world. And you're back into a different world until you can show that the stock is rebuilt where you can go back up. Well, the problem is that, as you saw in the last example, the determination of whether the stock is to the right or to the left of this point is very uncertain, and it has huge implications in terms of the management. So these are the things that we would like to avoid. So to conclude the remarks of this first part of the talk, which is more about the framework and the methods, we think that it's useful to have guidelines on the maximum time frames for rebuilding. These are useful for planning. They're useful for selecting harvest rates that are good in terms of the rebuilding goals. But the problem is when these time frames are actually expected to happen. So you have to force the nature to do what the law says that the stock should do. So the adjustments of rebuilding parameters to try to meet these original rebuilding time frames can lead and have led to abrupt changes in regulations, and they present very difficult challenges to the councils, especially in cases when it's not just that stock, but just trying to shut down that fishery will affect the whole complex. Then the change from the normal fishery management plan to a rebuilding plan can also lead to this very marked change in allowable fishing mortality and catch, and the basis for deciding whether you are one way or the other are very uncertain. So now I'm going to go to the second part of the talk, which is about the outcomes of the rebuilding plans. This is just a straight tally from these reports to Congress that show all the different stock categories over time. So you see, this is the total number of overfished stocks that had a peak close to 2002, I think it is. This is the previous one that we saw with the newly declared overfished stocks, and we see the green line and the other green, which are the rebuilt stock and the rebuilding, which is increasing progressively. Now, to try to understand what's behind these trends, we decided to go and look at the actual stock assessments for the stocks that were assessed by quantitative methods. And we found a subset of 55 stocks that had quantitative stock assessments, so that meant that they had an estimate of the time series of fishing mortality relative to FMSY and biomass relative to the FMSY biomass. And also, the other condition for being in our subset was that there were at least 3 years to evaluate the response between the day when it was declared, the year when it was declared overfished, and then 3 more years of estimates of SMSY, so that we could see whether at least fishing mortality was reduced immediately. This is the status of those stocks. The green dots, this is the same plot or similar plot that Rick showed before with the each dot is one stock, and you can see where they sit in the biomass and the fishing mortality axis. And these are the 137, I think he showed 130 stocks in 2012. The green dots are the ones that were in our subset. You see many of the green dots are on this happier corner, but some are still there, that meaning they're still sort of below, not rebuilt, and with high fishing mortalities, and some have not rebuilt, but at least fishing mortalities have been reduced, and we can expect progress. The main questions that we addressed for this subset of stocks was, first, how reliable were the classification, the initial classification of stock status that triggered the implementation of these rebuilding plans. So this category that the stock was overfished. The second was how successful was the rebuilding plan at reducing the fishing mortality. And the third was how the stock size are responding. So again, back to this, the figure that Rick explained, and we can see the typical sequence of stages leading to the overfished state, followed by rebuilding, starting with a fishery that is pretty much overfished, then exceeding the maximum capacity. The yellow is sort of approaching the overfished condition, and the red is when the stock is overfished, and then a rebuilding plan should be in place. If we go and look at the same plot on the right, is with the fishing mortality axis. We see the increase in fishing mortality followed with the decrease in biomass. This is what is crossing that limit, and that's where the rebuilding plan should be implemented, and hopefully that's the expectation. What you want is to see this counterclock movement of the stocks back to the happy, good, pretty good yield place. Now, these figures are very idealized because they don't have any uncertainty. We have a lot of uncertainty in determining the initial stock size and determining how much you can fish, in addition to determining what's this BMSY and FMSY level. So the first was to evaluate how much uncertainty there was based on the current assessment in the initial classification of the stock status. So say the yellowfin was in 2004, it was declared overfished, and now in 2012, we reevaluate the stock and go back and see what our current assessment says about the 2004 stock size. So these are the 50 stocks that we analyzed in our subset. If we look at how our current assessment placed them, so initially they were all overfished, so they should have been all in red. They should have been all below the minimum size limit. Now that they've been reassessed, some of them were not only not overfished, the blue ones, but they were actually above BMSY. So that meant the initial classification of that triggered the implementation of the rebuilding plan now is being challenged by the new assessment. We tend to use the most recent assessment as the best available science. I mean, that's because we have more data on all the cohorts that go into the fishery, but there is also the asymmetry in this. See, I'm sort of like using the most recent as the truth, and in fact, the most recent also has errors. But we see that there is only the red dots, which are 35 of them, were, according to the most current assessment, overfished at the time of the overfished designation. So the second question is how successful were rebuilding plans in terms of reducing the fishing mortality. We had the tall green bar. Those were stocks that at the time of overfished designation, they were not being subject to overfishing. So the idea is that if they had been left alone with that low level of fishing mortality, they could have rebuilt it on their own. The others had fishing mortalities that were exceeding the FMSY. The red bar are the stocks that are still being subject to overfishing. So 64% of the stocks that were subject to overfishing at the time they were designated as overfished, the fishing mortality was dropped down. So overfishing was halted for 64 of those stocks. In terms of biomass, similar plot. Now, the response here is more difficult because this is not something that we control, that we believe, or we want to believe that we can control the fishing mortality, but this goes through nature, and so not all the stocks are responding the way we expect. These are the 20. Remember that I said that out of the 55, only 35 have been reclassified were classified again as overfished. These were the initial ones that were either not overfished or were even above the BMSY. Of the 35 stocks that are now estimated to have been overfished, 10 have rebuilt, 15 are rebuilding, and 20, the red bar, are still in the overfished category. The problem with these previous plots is that they are like whether you are above or below. So they place too much faith on this classification relative to a reference point. And I think it's more important when you want to evaluate the impact of this management to actually look at the trends, and not whether you have been able to rebuild, but at least whether you're moving in the right direction. And I think the picture is more positive when we look at the actual trends. We start with Pacific Council. What I have is over time, the trends in fishing mortality relative to that limit, and the dashed line is before the overfished declaration, and the solid line is every stock, so one stock per line, and the solid line is after the stock was declared overfished. So you see the great majority of the stock, there is a substantial decrease in fishing mortality, in many cases preceding the actual declaration of overfishing. So, and this is to be expected because there was a lot of anticipation that this was coming. So a lot of action here. The other thing to notice is that it's the level of overfishing at the start of the plot, which is very different when you go from region to region. So these were most of these fishing mortality estimates were 50% above the limit to 100% above the limit. The responses, in general, positive. In general, positive. Not all of them rebuilt, but at least moving in the right direction. The Mid-Atlantic and New England Mid-Atlantic, also a very marked decrease in fishing mortality, but now notice that some of the stocks started at a much higher level of overfishing, but they were all now brought below the limit. And again, a lot of positive signs in terms of the stocks beginning to increase. The situation is a bit more mixed in New England, and I divided them into plots just because it was too busy. Now again, you can see in both plots that we're talking about huge overfishing rates. So this is, see, when in the Pacific this line was in the middle of the plot, here it's really above, and we're starting with huge fishing mortalities. If, it took longer, but we see a lot of progress in terms of bringing the fishing mortality down over the last few years. So it took longer from the time of overfishing declaration to now, but at least there is progress in that sense. And there is some exceptions that are stocks, the cod stocks, you can guess, that are still being subject to overfishing. Some progress, some of stocks are increasing, but again, a more mixed performance in New England. The other way to look at these trends is from the time of overfishing to the designation to the last year of the assessment, just look at the actual movement in time and how they moved in the phase plane, so in the fishing mortality versus biomass. So what we would like to have is, if stocks started here, so in the overfishing and subject to overfishing corner, then we'd like to see movement first here and first there. You remember that counterclock thing. And that's what we see. I mean, there is the odd arrow, but in general, they are doing what we would like them to do, even in New England. So this is the problem when these are not overfished. So when we're counting on the number of stocks that have overfished, we're sort of not seeing the real progress in reducing fishing mortality. Go across the other places. This is the same plot. The Pacific, you see how much lower the starting point was compared to this high overfishing level. So, but again, arrows tend to be moving in the right direction with some odd exceptions. Same thing in the Mid-Atlantic, and Gulf of Mexico is a bit of a problem. The important thing here is trying to see the change in biomass from the year of designation to the most current assessment. So positive here from 0. Positive is an increase in stock size. Negative is a decrease as a function of the mean fishing mortality that they've been exposed. So what you expect is that the lower the fishing mortality, the more positive changes you would see, and that's what we see. So there's an empty hole here. That means most of the stocks that responded when the fishing mortality was effectively reduced. There is these odd 5 cases that continue to go down even though the fishing mortality was low, and there is a mixture of some of them are like Pacific hake and haddock that have hugely fluctuating recruitments. The other is one of the crab, the blue crab, I think the Privilov, that has a regime shift explanation for that. But you can see that over the whole picture, in general, management does what it should. Fisheries tend to recover when fishing mortality is reduced. So overall numbers for the 55 stocks analyzed, and these numbers are up to 2012. Overfishing was halted in 23 of the 36 stocks that had fishing mortalities above MSY. 20 stocks were not overfished at the time of the designation, and 10 were actually above. So this is just a summary of what we've seen. Of the 35 stocks that were overfished, 10 have rebuilt, 5 rebuilding, and of the 20 that have not, at least 11 have fishing mortalities that are well below FMSY. 9 of the overfished stocks are still being subject to overfishing, even though the fishing mortality targets were set below 75% FMSY. Failures to achieve the intended reductions in fishing mortality. There's many explanations. We look at a few cases, and there is usually ineffective input controls and lack of accountability measures prior to 2007. Difficulties in reducing fishing mortalities of species that are caught as bycatch in other fisheries, and then the overestimation of stock size. And I leave it here because I think Steve Catering will sort of talk about this in detail. So final remarks. The mixed performance, we concluded that this was a mixed performance. Some people, the optimists in the committee, thought this was success. Others thought that this was failure, but it depends on whether you see the half glass full or empty. We all believe that there was a mixed and variable performance of rebuilding plant, and we attributed this in part to the uncertainty in the determination of stock status relative to the reference points, and the fact that these estimates of stock size and productivity would change often from assessment to assessment. The problem is that the current policy dependence on biomass thresholds and targets often triggers abrupt changes in management, exacerbating the impact of the inherent variability and the uncertainty in the stock assessment. So this is not a criticism of the science. The science is what the science is. The problem is that we see there is a bit of a mismatch between what the science can deliver and what the management framework is expecting from the science. So some key findings for considerations by science. I think this was our long way of saying recommendations that we were not supposed to give. So the first is that there is harvest control rules that gradually reduce fishing mortality as estimated stock size falls below MSY. They could actually reduce the likelihood of becoming overfished in the first place, and they would allow for rebuilding if necessary. So the idea and the recommendation, that is not supposed to be called like that, is that you combine the rebuilding plans into an actual unified harvesting strategy that would do both. And that would be smooth and avoid these discontinuities that have been so difficult to accommodate. The second is that the rules that have discontinuities, such as the 10-year rule used to set the maximum rebuilding time, are problematic because usually a small change in information or assumptions can lead to major changes in regulations, as in the examples that I showed. So we think that rebuilding plans that actually focus more on meeting these fishing mortality targets on average than on the exact schedules for attaining these biomass targets would be more robust to assessment uncertainties, to natural variability, and to ecosystem considerations. So basically, we plan for rebuilding, but we don't expect the stock to actually behave the way we would like it to. This is it. Thank you.